Well, thanks first of all, everyone, for sticking around for the last session of the day. It's funny, when I wrote this submission for this presentation, it was way back in like January or December, and no one knew what a foundational model was or a large language model was, and the tool chains were moving so fast. And what's been fun about this whole topic is that I've probably rewritten this deck 3 times, 4 times, just in how fast the tool chains have evolved. And even today, from yesterday's announcement, there's going to be parts in this that have changed. So as a nerd, that is a hell of a lot of fun. So let me tell you a little bit about me and what we're going to go through today. My name is Nick King. I founded a company called Datakinetic literally a month ago, but really I've been working on research on these technologies for quite some time. Before that, I've worked at companies like Google, Microsoft, DataRobot, a number of AI platform companies. And pretty much my entire career has been focused on enterprise platforms, applications, and what I would call kinetic decisions in production. So think dosing pumps and oil and gas refineries, think making high-frequency trades for Forex trading, really designing and delivering those types of platforms that have very meaningful impact when things go wrong. So today we're going to talk about rapidly scaling, and I'm going to use a couple different ways of thinking about how you rapidly scale, and particularly as the tool chains and everything's moving so fast, how you can stay and take advantage of that. So it's not always about starting from scratch. It's about starting from value. And I'll give you one or two good examples here, which is most CEOs I talk to have a very clear understanding of their problem. They're like, Nick, this problem, this fraud problem, this compliance problem cost me $60 million a year. And I'm like, great, I can solve it. He's like, how are you going to solve it? I'm like, we're going to change these processes and do X, Y, Z. Not a single C-suite has asked me what model I've used in an AI application for the last 5 years. It could be a box of bees that I shake up, and it could give them an answer. And as long as it works and saves them the money, it will make a huge difference. So the first thing about driving and scaling these models is your executive team, the business team, where the value of an application comes from has nothing to do with the math. So why is it so hard? It's so hard for a number of reasons. One is we focus on actually building these applications and getting the model to work, getting it to be an outcome. That's about 40 to 50% of the problem. The real problem you have to solve is how do you get this into production? How do you ensure the people that use it trust it? And how do you make sure that it doesn't make a bad decision? Unfortunately, if your model makes one bad decision, everyone remembers that. If it makes 1,000 good decisions, no one remembers that. And so there's almost this organ rejects host element when you apply AI to organizations very quickly. That means the organization will reduce and remove those applications. And so we've thought about a number of techniques to solve for that. We can talk about some of the ways we work with organizations to make organizations adopt AI faster. But also what we want to talk about is just how you reduce the time to create these applications. A lot of the time we'll build an application, and then 3 months later or 3 weeks later, a new tool comes out, and it dramatically just removed 2,000 lines of your code. Great, more efficient code. So what I'm going to cover today is some of the architectural design points to think about based on where we think the evolution of these models is going to go. So just a little bit of a level set on foundational models. I know that LLMs became this great thing, but foundational models really mean the ability to pre-train on a certain data set and have some form of transfer learning to some unseen data set afterwards. The ability to cold start or engage or make some inference from a foundational model is an incredibly meaningful and powerful element to apply to the way you think of your applied AI applications. A large language model is just one of those. So very typically in the enterprise, what we'll find with foundational models is you want to make a number of categorizations or inferences and be able to go through and identify those in a multimodal, multi-industry way. And so some of the foundational models that we look at, that you should look at, are not just about looking at how an LLM can answer the question, but how do you actually generate the extractions that are meaningful enough to power those types of decisions. I don't know if anyone was here in the presentation before, was the pine cone. And one of the things that stood out for me, which I 100% agree on, is we're all sometimes thinking if we just put the embeddings in a vector store, it's going to be okay. First pro tip, spend the time to organize the embeddings. It'll make a huge difference to your models. And the reason for that is when you search for something, if there's the right metadata, the right time series, the right grouping, you can have much more accurate results and begin to dramatically reduce the exposure to having what a lot of folks call hallucinations, but having misrepresented values. So now you think about these foundational models as ways of creating repeatable transfer learning across your organization. And obviously a large language model is one of those. Even things like LDA models, when done right, can be this. There's a number of ways of how you can take these models and apply them at scale. So let's take a common use case. Who here knows what ESG is? You've seen it in financial services documents. We all know that there's certain incentives from certain funds to have ESG stocks. It's a really interesting shift in the market where companies are trying to be very responsible at what they go and deliver to the world. I think that's a good thing. Now, what turns out happens is that most of these organizations have large teams to ensure ESG compliance. But imagine you're a large food and beverage supplier. So you might have solar panels on your roof, you might be building everything great, you've got a great diversity program, you're doing everything right. But you have a supply chain. And your supply chain is made up of tens of thousands of suppliers. And in order for you to be compliant, your supply chain has to be compliant. So what happens is you create a team to send all these suppliers a survey and say, please tell me you're compliant. And just let me paint a picture of how complicated this issue is. Who here knows what palm oil is? All right, so palm oil is a precursor ingredient that's used in so many things today. Unfortunately, palm oil is usually grown in less affluent or less controlled environments. It tends to be in other countries that may have good practices or may not have good practices. It's actually quite problematic to see palm oil supply chains actually have people like literal pirates who will come in and pump 30 tons of illegal palm oil into a 70-ton shipment of good palm oil. And what happens if you're a food distributor and suddenly your ESG supply chain is compromised? In fact, ESG now is becoming to actually be able to be valued. So ironically, British American Tobacco has a higher ESG rating than Tesla. And the reason for that is they're better at explaining how they deliver their supply chain. And they're also better at Tesla's not as good at being able to sort of explain everything it does. So there's very monetary value into maintaining the supply chain. Does this sound like a really complicated problem? Because it kind of is. So 2/3 of an organization's ESG footprint lies with suppliers. So you have 30,000 suppliers, you've got to figure out how on earth am I going to work with all these folks? Tough start. I can tell you how a lot of folks do it. They have an outsourced team of 4,000 people or 100 people, and they send surveys and they call up people until the end of the year. They build this report, and then someone says, I think this is right. Seems a little risky. So what if we were to apply large language models and applied AI to solve this problem? Sounds like it could be a good idea. So the first thing we want to do, if we think of this problem of a supply chain, remember there's pirates pumping illegal palm oil into these ships in the middle of the ocean and doing all sorts of terrible things. We first have to take a risk assessment and identify what's happening in the supply chain. So some suppliers could be really good. Some suppliers might not be. Most suppliers will actually explain what they do through a thing called a CSR report. And so you have to go and understand and assess what might be happening with that. The second thing is that things can change day to day. What if you get a news report that one of your suppliers had done something wrong or got caught up in charges? What if that news report happened to not be in English? What if it was in a different language? How do you as a supplier, how do you augment this information and do something very specific with it? The next thing is you have to be able to predict, was that good news or bad news? When you go through the ESG reports, the reports your suppliers provide, they're very unstructured documents. Everyone's on the phone, if you look up like Walmart ESG report and have a look at it, it's 60 pages of pretty graphs, pretty charts, lots of words, an almost impossible thing to extract. So you have to be able to start to predict like what was the value of certain criteria and how do you score that? The next thing is you have to figure out what we call decision support. How on earth do you know out of your 30,000 suppliers who to go and engage, and why should you go do that? And then finally, how do you engage your stakeholders? At the end of the day, a CFO has to sign off this. So if they sign off and it's wrong, and suddenly a report comes out that they had a tainted supply chain, this is really bad. Like billions of dollars are bad for certain companies. So enough of a problem set. I chose a hard problem because they're way more fun to solve. And if we can solve this hard problem, the easy ones get way easier. So the way we solve this is first around, for large volumes of unstructured data, we're going to talk about extraction and vector DBs. The previous presenter had a great presentation on using Pinecone. I think also we'll talk about how important extraction and organization of head data is before that. The other thing is how you create baselines and how you can actually use blended AI ML pipelines to actually deliver far more accurate outcomes for a large language model. And I'll also talk about why doing it this way allows you to effectively lock up the model and ensure that you don't have drift occur, or effectively concept drift occur. So you're actually able to checksum what's coming out of the LLM. The other element here is we're going to try ingest the entire world's global news, and we're going to try to turn that into a model. That's a fun piece of work. If anyone wants to see how crazy this is, look up GDELT and look up this. Basically, they provide the world's global news. If you put it in your browser, it will crash your browser. But we're going to figure out how to do that with an LLM. And then finally, we're going to talk about how we use the large language model to summarize and use the ML models to heat map and ensure we keep those in sync. So with all this document and data moving around, you have to keep this data in sync. So what does the architecture look like? And I'm sorry for a complicated architecture diagram, but we're going to talk our way through it. So on the left here, what you see is effectively the documents we're getting. These are ESG reports. These are reports that companies provide. Or what's called a CSR report, which is a third-party auditor report. And there's two things that are going on here. You'll see the first piece here is us extracting and passing it effectively into the vector database. But here's what's important. What you see here happening is actually some level of organization for these reports. And this is where a lot of times you'll make mistakes trying to scale these large language model applications. So what's a common thing you would look for to understand the performance of an organization? Usually you look at what did they do last year compared to this year? What happened yesterday compared to today? You're usually doing some form of time series orientation. So as we do these extractions, what we also do is we start to organize and create metadata to refer back to what our sort of aggregation needs to be for that data. So thinking through how you're going to consume that, what the outcome might be is really important for how you pre-process and prepare to deliver your embeddings into your vector store. The beauty with this is that when you do your search on the other side, you've already organized the relationship between those and you already have the metadata and the aggregations, which means you have much more accurate outputs from the vector, and that when you pass context and ask for summarization or some level of agent inference, you're much more likely to get an accurate answer. So you're like, all right, Nick, that sounds really cool, but how do you deal with hallucinations? How do you deal with it not making things up? So the next part I want to talk about is you see this thing called DK extract. That's actually a model we built that's effectively a foundational model that allows us to extract any document and basically turn it into JSON, and it does a bunch of things around industry awareness. And so what I'd recommend for you is as you're thinking through your applications, think about how you extract core pieces of data and as opposed to vectorizing them, move them into a feature store. Begin to make some level of inference from that data that you're extracting. And here's why this is really important. Because as you create this feature store, you can start to say, hey, here's a summary of this change. Here's the chemical dosage for this pump. Here's what we think is happening over time. Here's the financial ratio between these two businesses. And you generate a feature store which becomes really a representation of what you put into the vector store. And then we actually take that feature store and we inject it also into the vector store. And we do that in a form of metadata, and effectively we create a reference point between those embedded vectors and what we think the ML, the traditional statistical model, would be. And the reason we do that is when you pull that search query, you're going to get a query that includes the content, the aggregation, and also effectively a checksum saying, hey, is this relating back to some inference we'd made before? Everyone kind of following with me so far? Hopefully. So now, what we do on the right-hand side here is we do our typical, sort of on the bottom right, we do a typical agent call. We'll go through and we'll call the front end. The front end goes and does a similarity search. It passes back to vector. At the same time, we'll have that checksum, and we'll say, okay, here's the values we think it are. We'll then match those against these topic models, ESG models, prediction insight, and we'll say, do these strings match? Does the actual output match what we're inferring from our feature store? We kind of call this concept locking. And basically, the reason why we do this is that it's very hard to hallucinate when you control both sides of the equation. So the beautiful thing with large language models is they're Socratic. That also means they never compile the same, which means that there can be mistakes made. But if you can control the data on the way in and you can validate on the way out, you're halfway there to making sure you're not going to have hallucinations. And the beauty with that is once you can have that type of guarantee, then you're very quickly able to have a lot more confidence to pass that data throughout the rest of the organization. A lot of the times when you put these into production, most of your time is spent solving two questions. How do you stop it from hallucinating, and how do I not lose my data? And that pretty much is most of the blockers I hear from enterprise customers doing that. So the next question was, how do I stop your data from leaving the organization? And so you'll see across the bottom here, there's really 3 agents. And I think our thinking on agents has evolved a lot. Our thinking now is rather than having general purpose agents, think of agents of excellence. So we design the agent to have one very specific task. That agent of excellence is able to go through, ask a specific task, deliver a specific task, and cannot do anything else, but it also means we understand what's coming back. And then the beauty with this is you could effectively keep all of your company data private on this side of the equation. You see that arrow going between, like, say, OpenAI and other third-party models. We actually can generalize prompt queries to solve other problems that might come up. So what we think happens in a lot of these models and what we're seeing is summarization is actually a relatively consistent process. We can see that from Dolly, from Falcon, what have you. But other models are much better at code gen. GPT-4, GitHub's model, really good at code gen. GPT-4 is really good at doing what I call like instruction breakdown. So if you say, please make a chair, it will actually go through and give you the instructions to make a chair. Now, it's a really powerful piece of information to pass back to an agent. But you don't want to pass the please make my chemical program and send that to OpenAI, but you could say, what's a typical chemical decomposition process? So you can generalize queries and make use of models of excellence as well as agents of excellence. Now, the reason why this is important is I think we're going to see this happen very quickly. I think we're going to see lots of these open source models become not as much generalized like summarization type models, but we're going to see more of these very specific, much more well-trained open source type models. And that allows you to think of an agent of excellence and model of excellence approach. So this architecture, we've deployed it 2 or 3 times now. Effectively, this first training cycle takes a little bit of time, but then after you've kind of got it up and going, you're able to inject the data almost on a daily basis. It's not too expensive. We've had a couple folks do their own private models. You know, mileage varies. Generally, we see like Falcon is doing a pretty good job of landing this, and then we do the gap between the two where they're generalized to other external models. So this is the bit I was joking about, which was this slide was really relevant a couple days ago. As of this week in the announcements here, it's not so relevant anymore. So now there is VectorDB coming from Databricks, which we'll happily try to make life way easier. We use Feather, for an example. It's something LinkedIn produced. The reason we use Feather is it allows us to do both batch and real-time feature management, and that allows us to actually compare the features as they evolve. So another thing we do in Applied is we look for what we call feature drift, and so often we'll see the features will start to be drifting before we can pick up the data or model drift. And the reason we do that is if a chemical dosing pump or something else goes a little crazy, you want to stop that thing as fast as possible. And so data drift usually takes, a snapshot. It's generally like a 30-minute, 2-hour, 3-hour thing. That's a long time for a pump to be dosing incorrectly. Model drift tends to get picked up sometimes, not sometimes. You lose a lot of confidence. So by looking at feature drift, we're actually able to make some pretty quick decisions when we break things down. FAS is a tool that Facebook released. Worked great, but I would recommend Pinecone or others. We just use it because it was easier for us to deploy, and it meant that the data stayed on-prem. So, how does it work? Effectively, we first of all generalize the reports themselves. So we create an LDA model. Those familiar with LDA models, they're actually quite elegant. They're a nice way of grouping topic areas together. They also compress really nicely and they're really scalable. So effectively, you take a large corpus of all these CSR reports you've extracted, you take that data, and then you're able to go through and map these themes together. So effectively, you can say, okay, which of these different elements and which of these themes. And then the second side is we go and take all the news from around the world. We then go sort that, and then we figure out, was what they're saying in the news, was it positive or negative? And how does that relate to their score? And so effectively what you say is, if someone says they're really good, but all the news in the media is really bad, you probably should go talk to them. But if someone says they're really good and all the news is really good, they're probably going to be okay. And so that's how we look globally to assess, is this vendor have something going on? They might be telling you the perfect thing to your face, but if the news is saying something different, you probably need to go and investigate. And if you're checking that every single day, then you know what to go look for. So I'm going to show you some of this. The large language model stuff is a little complicated to sort of run through. The diagram does it better, but what I will show you, and how do I get to? It's this one. Where are we? I guess I'm opening up my sorry guys, I just got to find the right window. Nothing like a real-time demo. There was another window. All right. Click and drag it right. All right, I can go off this one. Okay. All right, there we go. All right, so effectively, where's my cursor? Here we go. It's a little tricky to do this in both directions. All right. All right, so effectively, CSR reports are the reports that go through and get assessed. And so we effectively go grab all these. It's basically our document extraction, bunch of data prep. Effectively, we go through, clean this all up, and then effectively we teach the topics, build the LDA model over time, and so you end up with effectively a model that looks like, where's the pretty picture? That looks like this. And so this model, this LDA model, allows us to create a series of groupings that we then can apply in stream to the large language model that allows us to scale. And the beauty with this is the LDA model you can train once and have inference. And so when we talk about scaling these large language models, a lot of the times we're trying to make the large language model really stretch very far to go do it. You know, we're trying to get the large language model to answer these questions, try to get it to do some sort of classification. So the first tip here is, as you scale these applications, actually pre-build some of these components and embed into those vectors the ability to reference these. And that goes a long way to solving how you actually can scale this part of the platform. And so ultimately, you can sort of see it talk about risk and management, and at the end it classifies all of the different news and data as one of these types of scores. And so that's the sort of the second tip for how to scale is, don't overburden your large language model. Don't overburden the training cycle. Try and pre-do some of the key insights and then reconvene them as those vectors come, as those search queries run. The other beauty with this is I actually think we keep finding the tool chains are getting better and better. And so when you don't overly burden the tool chains, you're also able to quickly update and move things through. So in the very beginning, we spent a lot of time making these complicated lang chains. Now, effectively, we spend a lot more time thinking about, okay, what services can we make available to those? How do we have agents of excellence and models of excellence, and then allow those to scale out more rapidly? All right, I'm going to try and go. All right. Is that the share button? Yahtzee. All right. So what you see here as we bring it all together, we're pre-building those models. We're pre-building those models as part of what we saw. We've architected our large language model architecture to allow us to stack those models around it. We've thought about how we do extraction, and we extract it and we create those embeddings in a way where the embeddings themselves create and contain their own metadata, validate them. And then on the search, as we take the agent, we actually go back through and try to understand, is this the result we're expecting? And effectively, as you do that, it makes a huge difference in how you can scale these applications. So how do you prevent hallucinations and build trust? So I talked a little bit about how we have the way we build and organize up front. The other thing is to create what we call control loops. And so effectively, as you go through your prompt chaining, being able to go back through and actually ask a protagonist and antagonist question of the prompt, and then compare those two and see how different they are. And the reason why we like to do that is sometimes if you do a protagonist and antagonist prompt, but you get a relatively similar answer, again, it's likely there's something else going wrong with the model. So there's just some tips there on how to question the model enough so you can ensure validation. The other thing we do is we effectively look for concept drift. There's this tool that I like because it's kind of visual for this presentation called PromptFoo. There's a bunch of these out there now. Effectively, what you want to do is set up another task that goes through and asks common questions and look to see if something changes. This one can be quite fun. We actually can tell when certain models are being retrained or they're going through a reinforcement pass. We can often see when there's dips in performance. And also sometimes you'll get, someone will get a little exuberous and bring a whole lot of extra blob storage into your model, and you start getting weird stuff. And so this is a very good technique just to keep an eye on it. It's kind of like peace of mind. I wouldn't necessarily stop the whole business if this goes wrong, but as you're thinking about the complexity here, it's a nice way of pragmatically viewing it. Temperature always 0. Never let it be creative. If you're building enterprise stuff, it's always 0. Do not let it be creative at all. And then the other thing to ensure that you don't have this is we've all seen the RAG method where you take effectively the context of only the context and you use only that context to present a response. So effectively you set creativity to 0, you only give it the context you need, you've already checked it, and at this point you've now got a relatively high trustworthy large language model that we've yet to make them hallucinate and we've tried pretty hard. So the other thing here is how you configure retrieval. This I think is an area where we're all going to get a lot more sophisticated. How you build those search queries, how you think about how you aggregate those search queries and reconstitute those queries is really where we're seeing a lot of value with customers right now. It's also where we think that agents will evolve a lot more. So I talked about having very specialized agents. What I do believe will happen here is these specialized agents will also have certain ways they might be searching through the data to get a different outcome. And so definitely as you start to develop these search approaches, add in your validation at this step as well, but also begin to think about, can you use agents and agent configurations to make this more efficient? Where I see a lot of folks go wrong is they embed poorly, they don't put enough thought into the embeddings, and their search queries are too broad. And then as the model goes to summarize, the context that it's summarizing has weirdness in it. And that weirdness forces the model to maybe put something else, the attention cycle is incorrect. All right, so the next piece I want to talk about, because I do want to give some time for some questions, how you do the agent configuration, prevent sensitive data leakage. So this last piece is how we effectively do the agent configuration and having multiple agents that act as experts. So generally we have rules that live in the customer site that are specific to the outcome. And then also we may have a translation agent which will know how to go ask for certain things. So the one I talked about, like making a chair, the actual one we typically do is like, can you please give us the chemical composition for a certain XYZ coagulant? Bring that back and explain to us, are there any variables for that? And effectively it can give you the sort of chemical breakdown of how to build that formula. Nothing shifts from outside the organization, but it gives us the flexibility to bring more into the model if we have to. We do a bunch of checks. And we are starting to see some specific large language models that are interesting. Microsoft just released one a few months back called BioGPT, which is effectively all medical text, can also be quite helpful. So we're starting to see these much more hybrid model approaches. So again, for agent configuration, maintain boundaries, but also when you need to, done right, you can traverse those boundaries and still maintain customer security. So what does this look like? This is one of our use cases here for the supply chain. So effectively, from all that, we're able to audit all the suppliers, ask the questions, provide recommendations, and this typically would take a large organization, many, many months and many, many people calling. In this solution, we're almost completely automated. Effectively, the only thing that we don't automate is if the customer their supplier doesn't have the report, we'll actually give guidance for the team to go do the report. But I think soon we'll actually create an agent which will go out and actually do the report and actually ask questions of that supplier, and so they'll self-generate their own CSR report, which I think is kind of interesting. At a certain point, we could almost have the system self-regulate the entire way you're working with these complex data sets. So I want to talk about some best practices. Start small. I talk to a lot of folks, and they tell me how they're going to build this massive system, and they're building jumbo jets that can fly to Japan that have 10 tons of cargo and are aerodynamic and run on biofuel. Awesome. We all want that, but first you've got to build a plane. You've got to build your Wright's flyer first. So start with one simple project and start there and get that outcome, and then add to that, and then add to that some more. It's very easy in enterprise to just pile everything on for this perfect solution, but you really do have to start small. The other thing is stay true to where we started. We were all data scientists before. These models are really cool, but the AI, the ML use of this and the statistics and using even physics models are really powerful. I'll tell you that a large number of what we deploy actually starts with a physics model, not a math model. We're actually doing some form of like pre-processing to ensure that we do things right. And the reason we do that is we know that those are generally cover 80% of the use cases. That last 20% we can fill in with the ML and AI. Do not underestimate this. The embeddings are probably the biggest place to make efficiency right now. And then take the time to understand the models. They actually are starting to show some derivation. Most of the open source ones are very good at summarization. I think that's a pretty good task where most of us are seeing it. Things like coding, things like debugging, things like instruction set creation, those are a lot more specialized. And so you can't just get away with necessarily having one model to fit them all if you're going open source. So those are some best practices. And so just a little bit about me. We build this extraction tool, multimodal. We actually built that out of frustration because we were sick of building embeddings. So we built a custom neural network to go build that. We do private LLMs at scale, and so generally we won't build LLMs for LLM's sake. We always focus on applied outcomes. So we're usually talking to oil and gas, financial services, retail, healthcare. We very rarely talk about the models to our customers. We usually talk about building from there. And then finally, we have effectively an outcome catalog. So you choose an outcome, and we help you go build that. Just over the last 20 years, we've seen so many different outcomes and applications. We thought, why not share some of those blueprints? We won't go into how it works. So that's it. I think we've got a few minutes for questions.